Good morning, children. Today we'll continue with E part of this chapter, gravitation. In the previous video, I just started a bit, but there are quite a lot more to study. So today I'll be explaining all that. Okay. The first thing you have to study is state Newton's law of gravitation. Okay. So this is the fourth law by Newton. Newton's first law, second law, third law. Now Newton's law of gravitation. So what does the law say? The force of attraction between two bodies is directly proportional to the product of their masses and inversely proportional to the square of distance between them. Okay, so the force, the law itself is the formula. Okay, so according to Newton's law of gravitation, okay, we are assuming two bodies of mass m1 and m2. They are separated at a distance r from each other. And so the force of attraction between them is directly proportional to m1 into m2, product of their masses, and inversely proportional to square of distance between them. So this is what the Newton's law of gravitation says. Okay, directly proportional to product of masses, inversely proportional to square of distance between them. Now, based on this law, based on this Newton's gravitational law, we get the formula for force of attraction between any two bodies. So combining these two, you get F is proportional to m1 into m2 upon r square. m1 into m2 upon r square. To remove this proportionality sign, I have to introduce a constant capital G m1 m2 upon r square. Now, capital G, you all know about small g, that is acceleration due to gravity. That is different from this g. Okay, now what is this g? This g is called universal gravitational constant. Universal gravitational constant. So it has a particular value, okay, everywhere on the surface of Earth. Okay, and its value is found to be 6.67 into 10 power minus 11 Newton meter square per kg square. Okay, Newton meter square per kg square. Now, how did I get this unit? Newton meter square per kg square. I'll show you. Now, F is equal to G m1 m2 upon r square. Now, I have to find the unit of G. So, keep G alone this side. Bring the other terms this side. So, F into r square upon m1 into m2. F, unit of F is Newton. R square is meter square upon kg square. Mass into mass, so it is kg square. That's how I get the unit of universal gravitational constant as Newton meter square per kg square. Or in your book it is written Nm square kg minus 2. Either you write upon kg square or into kg minus 2. Okay, so this value you're supposed to remember, 6.67 into 10 power minus 11. You have to memorize this value. Now open your book. So this is the formula for force of attraction between two bodies, F. Okay, G m1 m2 upon r square, where G is called gravitational constant, universal gravitational constant, and SI unit of G is Newton meter square into kg minus 2, and its value is 6.67 into 10 power minus 11 kg. Okay, all these three things you have to memorize. Okay, now, right, now what is the significance of the value of G? Now, according to Newton's law, okay, any two bodies on the surface of Earth. So let us assume two boys. Okay, one boy is Ravi another boy is Ram. Okay, Ravi weighs 50 kg and Ram also weighs 50 kg. And they both are sitting at a distance of 1 meter. Okay, the distance between them is 1 meter. Are you able to imagine? Two boys sitting at a distance of 1 meter. You can imagine how much is 1 meter. Now, according to Newton's law, the law says there is a force of attraction between these two bodies. Okay, so between any two bodies. So you're sitting with your friend friend in the next chair. According to Newton's law, there is a force of attraction, but we don't feel any force pulling us or um, okay, so we have to understand why. Okay, so let us do a simple calculation. Okay, so we are going to calculate the force of attraction between these two boys, Ravi and Ram. Now, according to my formula, G m1 m2 upon r square. G value is 6.67 into 10 power minus 11. M1 is mass of the first person is 50 kg and mass of the second person is also 50 kg. R mass I take 1 meter. Okay, so 1 square. Okay, so when I do this multiplication, 6.67 into 2500 into 10 power minus 11. Now 1 square is 1. Okay, if I multiply this value, I will get 16675 into 10 power minus 11. If I multiply this, I get this value. Now, now if I bring this 10 power minus 11, okay, if I try to write it in decimal, okay, so 1, 2, 3, 4, 5, already 5 digits are there, okay, and then I'll have to have 5 more zeros in front, 16675. This number, if I have to write it in decimal, it will be like this. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, one more zero, 11. This much Newton is the force. And this value is very, very small. See, 0.000000166. It will be a very, very small value. So the conclusion is between ordinary bodies, okay, normal human beings or any ordinary bodies, the force of gravitation, the force of attraction comes to be very, very small or insignificant. We can say insignificant. That's why even though they both are sitting at a distance of 1 meter, they don't feel any attraction between them because that force is very small or insignificant. Okay, mainly this is because of, if you see the value of G is very small. See, 10 power minus 11 means it is very, very small. Okay, in the sense, like if I write this in decimal, then I have to put 10 zeros before this. Are you able to imagine? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 6, 6, 7. Okay, this, if I have to write in decimal, is this much, which is a very small value. Now, because G is very small, okay, in case of ordinary bodies, the force also becomes very, very small. Or we can say, practically, there is no force of attraction. That's why normally we don't feel any force of attraction. Now, the same thing, let us calculate between Ravi and Earth. Okay, now Ravi is standing on the surface of Earth. So this is Ravi. So one body is Ravi and the other body is Earth. We are going to calculate the force of attraction between Ravi and Earth. Okay, so the distance between Ravi and Earth will be basically the radius of Earth. Now basically we'll take the center of Earth. Okay, attracted, law of gravity says it will be attracted towards the center of Earth. So we have to take the distance between center of Earth and this person who is on the surface of Earth. So that will be nothing but radius of Earth. Radius of Earth. Yeah. Okay. So one body is Earth. So I have to take mass of Earth. Okay, the other body is Ravi. Okay, let's take his mass as M. Okay, now force of gravity will become G. One body is of mass small m, the other body is of mass of Earth upon radius of Earth, the whole square. I hope you're getting the point. We are calculating the force of attraction between Ravi and Earth. So we have to take mass of Ravi and mass of Earth, and distance between them will be the radius of Earth. Now, these are standard values. Okay, mass of Earth and radius of Earth, they're all standard fixed values. Radius of Earth is 6.37 into 10 power 6 meter, and mass of Earth is 5.96 into 10 power 24 kg. Okay, don't have to memorize, just try to understand. So, can you see? They are very big values. See positive power and see the number. This is 10 power 6. Mass you see 10 power 24 means 596 followed by 22 zeros you put. That much big is the mass of Earth. Okay. Now, let's put it in this value. Now, G is always the same. 6.67 into 10 power minus 11. Mass of Ravi is, so let's take mass of Ravi is 50 kg. Mass of Earth 5.96 into 10 power 24 upon radius of Earth 6.37 into 10 power 6, the whole square. So now if I solve it, okay, so I have already done with calculator because it might take a long time. Okay, and then so these three numbers multiply, then powers 24 minus 11 upon 6.37 into 6.37 into 10 power 12. 6 2s are 12. Okay, now this alone, the value of this I did in the calculator, it comes out to be 49. This value comes out to be 49. If you want, you can check. Okay, this into this into this upon this into this comes out to be 49. Now, let's solve for 10 power. Now, 24 minus 11 is 13. So, you have 10 power 13 upon 10 power 12. If I solve these two, I'll have 10 power 13 minus 12, that is 10 power 1, that is 10, 490 Newton. So, between Ravi and Earth, the force of attraction is 490 Newton, which is a significant value. Means it is quite a value. You can't just neglect it. It's quite a significant value. Okay. So, the conclusion is, children, if it is ordinary bodies, the force of attraction between them will be very, very small or insignificant. But even if one of the body is a heavenly body, then because of this large mass of the heavenly bodies, your answer will become a significant number, which you cannot avoid it. So the conclusion is like this: force of attraction is insignificant between ordinary bodies, but it is significant between heavenly bodies. Now the thing is, now you have calculated, even if one heavenly body is there, it will be significant. I can also calculate, similarly, I can also calculate the force of attraction between moon and Earth. So I have to calculate one body as moon, other one as Earth, mass of moon, mass of Earth, distance between moon and Earth, and all that you have to take. And see, they have done the calculation. Gravitational force of attraction between moon and Earth comes out to be 2 into 10 power 20, which is also a big number. Okay, so the conclusion is the gravitational force of attraction is highly significant between heavenly bodies, but it is insignificant between ordinary bodies. Not necessary both should be heavenly body. Even if one of them is a heavenly body, you will get a significant value. And all this is because of the very small value of G. G has a very small value, 6.67 into 10 power minus 11, which means it is a very small number. Okay, it is because of this that you have this conclusion. Hope you have understood, children. So, this is a very important conclusion. So, these calculations and all, you don't worry. To just make you understand, I did the calculations. You don't have to memorize anything. So now, the next topic will be characteristics of characteristics of gravitational force. Characteristics of gravitational force between two masses. One is it is always attractive. Okay, it is always attractive. There is never a repulsive force. Gravitational force is always attractive. Second, directly proportional to product of masses, inversely proportional to square of separation between them. So when you write it as characteristics, you write till this, that's enough. And the fourth point, so 1, 2, 3 and fourth characteristic is significant between heavenly bodies but is insignificant between ordinary bodies because of small magnitude. Magnitude means value. The value of G is very small. Okay, this is one possible question. What are the various characteristics of gravitational force? Now, in this, I have written a logical question. Now, force of gravity is inversely proportional to square of separation between them. Now, there can be logical questions based on this. Okay. Now, so m1, m2, distances are, suppose if the distance is doubled, if the distance becomes 2r, then what happens to your force of attraction? m1, m2 upon 2r the whole square. Now, m1, m2 upon 2 square is 4, 4r square, or 1 by 4 of my original value. See, this is the original value. So, suppose when these two bodies, when the distance was r, m1, m2, when the distance was r, if the force of attraction between them was say 5 Newton, sorry, it was 20 Newton. Okay, let's state when they were at a distance r, the force of attraction was 20 Newton. Now, if the distance between them is doubled or distance becomes 2r, now the force of gravity will become 1 by 4 times of the original force, that is 20 by 4, it will become 5 Newton. Are you able to understand? When the distance was less, force was more. As you increase the distance, force becomes less because they are inversely proportional, and that too inversely proportional to square of distance between them. So this makes a large difference between these two. The other possibility is if I say the two bodies, okay, initially they were at a distance r, and now I bring them closer and the distance between them is r by 2. Distance between them is reduced by 2. Now what happens to the force? 1 by m1, m2, even if you don't write, it's okay, r by 2 the whole square. So 1 by r squared by 4, or 4 by r square, or f is increases by 4 times. F 4 of this one. Okay, so if in this case the force was 20 Newton, in this case the force will be 4 times of this, that is 80 Newton. Can you understand, children? So this is, you can have logical questions based on this. Distance is increased by 2 times, or distance is increased by 3 times. Okay, so it will become 9 here. Then force decreases by 9 times. Force decreases, if distance increases by 3 times, force decreases by 9 times. And if distance decreases by 3 times, force will increase by 9 times. Are you able to see this inverse relationship? Okay, inversely proportional to square of distance between them. Now this has in maths they call it inverse square law. This kind of a relationship is called inverse square law. Okay, thus by doubling the separation, the force between them is reduced to 1/4. So you can write, you can have logical questions based on this. They can ask you anything. If the distance is decreased by 3 times, what happens to the force between them and things like that. Okay, children. So then the next important thing is importance of law of gravitation. Where do they use it? Newton used this law to explain the motion of planets around the sun, motion of moon around the earth, and motion of freely falling bodies. Okay, so you can, this they ask in 1 mark or 2 marks sometimes. Where is mainly this is used? It was used to explain the motion of planets and all that. Okay, now we go to force due to gravity. This you all know. Force due to gravity is the force with which earth attracts a body towards its center. Now, so in this case, the force due to gravity, if I take force due to gravity, Gmm upon capital R square, means this is mass of Earth, this is the mass of the body, this is like a body of mass m. So when you have to find force of gravity, it is between a body and Earth. So one body will consider mass of Earth, other other body is mass of small m, and radius will be capital R. So your formula will become Gmm upon R square. Okay, that's what they have given here. And if you take a mass of 1 kg, then this force comes out to be 9.8 Newton. We took the mass as 50 kg. In the derivation that I did, we took the mass as 50 kg. So we got 490 Newton. Are you able to see the difference? They have taken 1 kg, so they got 9.8 Newton. If you take 50 kg here, you will get 490 Newton here. Anyway, then comes acceleration due to gravity. What is acceleration due to gravity? The rate at which, so you know that because of gravity, because of force of gravity, if I drop any body down, its velocity increases. Its velocity increases, or I can say it undergoes acceleration. So whenever a body is falling down, its velocity increases. That means it is undergoing acceleration, and that acceleration is called acceleration due to gravity, represented by letter G. Represented by letter G. Now the value of G, as you know, on the surface of Earth, it is 9.8 meter per second square. This is a average value. The value of G slightly varies from place to place. Now, suppose you know that the Earth is not a perfect circle. It's somewhere like a sphere, okay? So if this is the center of Earth, so this is the equator and this is the pole. Generally, poles are closer to center of Earth than the equator. Do you agree with me? Poles are closer than equator of than the distance between poles and center of Earth is less, and distance between equator and center of Earth is more. So if a person lives in pole, okay, North Pole or South Pole, the G will be less because he is much closer. Okay, and if he is no, it will be maximum at poles because of inverse relationship as the distance. So let's take this is R and this is capital R. So you know that R is less than R. So G in poles is greater than G in equator. Acceleration due to gravity in poles is greater than acceleration due to gravity in equator. Okay, so this change is not so much. Okay, so in 9.8, so in poles it might be 10 or 10.1 or 10.2. The change is not so much, but definitely it will be slightly more than equator. Okay, so and another thing you should know is the value of G. Now this is the surface of Earth, and imagine there is a mountain. Okay, this Ramu is climbing up the mountain. So we calculated when he was on the surface of Earth, okay, the force of attraction came out to be 490 Newton, or G will come out to be 9.8 meter per second square. Now this Ramu is going up. He's climbing the top of a mountain. He's climbing at the top of the mountain. So what happens to the distance between him and the center? This distance increases. This distance increases. As he goes higher above mountains to high altitudes, the distance will increase. So what happens to G? G will decrease. So if you go to higher altitudes, G will decrease. It will be slightly less than 9.8 meter per second square. Slightly less than 9.8 meter per second square. Now what happens? Now Ramu has decided to, okay, he's working in mines. and so he has to go inside the surface of earth. Okay, so there is a mine here and he goes here to work. Now when he is here, the force of attraction or the force of gravity between them, because now the distance between them is decreased, the distance between them is decreased, but so force of gravity has to increase, right? But force of gravity again decreases, force of gravity again decreases. Now that's because the mass will also change, because when he is here, you should only consider this much mass of earth, you should not consider the whole mass of earth, you should only consider this much. So, though r is decreasing, accordingly mass will also decrease. So children, you have this in 10th standard, so let's not break our heads. I want you to write these 5 conclusions. Either you underline it, if you can write it here as conclusions, that will be fine. Value of G: maximum at poles, minimum at equator. Okay, maximum at poles, minimum at equator, 0 at the center of gravity. Why? If I have to find the force of gravity between a body at the center of earth and the center of earth itself, distance will be 0. So G will also be 0. Then it decreases as we go up, means go to higher altitudes, and it decreases as we go down, as we go inside mines. These 5 conclusions you're supposed to remember. Okay, then you have relationship between small g and capital G. Now from this, F is equal to m into G, G m upon r square. You know, F is equal to ma, or if I had to write for gravity, so this m and m will get cut. So I have the relationship between small g and capital G will be small g is equal to capital G into capital M. Universal gravitational constant into mass of earth upon radius of earth. So this is acceleration due to gravity. And its value, if you put all these values, it comes out to be 9.8 meter per second square. Okay, free fall I have explained earlier. Okay, I think that's all for now. Thank you, children.